Number 4, find the reference angle for 16 pi over 9. So if I start at 0 and go halfway around the circle on my graph, then this would be pi, which is the same as 9 pi over 9. Come all the way back around to 2 pi, 2 pi. It's going to be the same thing as 18 pi over 9. So then halfway between 9 and 18, I mean, I know 16 pi over 9 should be in quadrant 4 because of this. But if 9 is that, 9 pi over 9, then this would be 9 plus half of that, so 4.5 over 9, which is ugly, 13.5 pi over 9. So we wouldn't really write it like that. If I needed to know this quadrant for some reason, I would double both of those and say 27 pi over 18. That way I don't have a decimal in my fraction, but that's not the point of this problem. So 16 pi over 9, going counterclockwise, I need to come close to 18 pi over 9. This is happening because there are, in case you didn't watch the other videos, there's exactly 9 angles evenly distributed on each half of the circle. So the top half from 0 to pi, you could break this up 9 times. So 1, 2, 3, 4.5, and 5, 6, 7, 8, 9, something like that. And so you're talking about how many of those angles are you going through. So again, my 16 pi over 9 is drawn right there in quadrant 4. I want to find the reference angle. The reference angle is drawn vertically to the horizontal axis. And it represents that distance or the angle measure of that acute angle. It's always an acute angle because it's referring to an angle to quadrant 1. Every angle in quadrant 2, 3, and 4 have the same trig values as the angles in quadrant 1 after you take into consideration the positive or negative signs. So from 16 pi over 9 to 18 pi over 9 is a 2 pi over 9 reference angle. So 2 pi over 9, because if I'm at 16 and I need to go up to 18, that's 2 pi over 9. So for example, if I took the cosine of 2 pi over 9 in quadrant 1, or I took the cosine of 16 pi over 9 in quadrant 4, those would be the same exact decimal value because those are both positive cosine values.